Myself, I am Surekha, lecturer in physics, Government Degree College, Pittapuram. Today's topic is dielectrics. Dielectrics are the substances which do not contain free electrons. In dielectrics, electrons tightly bonded to the nucleus of an atom. In this dielectrics, electrons are tightly bonded to the nucleus of an atom. ఆటంలో ఉన్న న్యూక్లియస్కి ఎలక్ట్రాన్స్ అనేవి టైట్గా బౌండ్ అయి ఉంటాయి. దే డు నాట్ కంటైన్ ద ఫ్రీ ఎలక్ట్రాన్స్. స్వేచ్ఛావేశాలు ఉండవు. అటువంటి పదార్థాలనే రోధకాలు అంటారు. ఎగ్జాంపుల్స్ మైకా, గ్లాస్, ప్లాస్టిక్ ఎట్సెట్రా. వాట్ ఈస్ ద ఇంపార్టెన్స్ ఆఫ్ డైఎలక్ట్రిక్స్? ఈవెన్ దో దే హ్యావ్ నో ఫ్రీ ఎలక్ట్రాన్స్, it is used to increase the capacitance of a capacitor by storing the more charge on the capacitor. It is also used to decrease the space between the two plates of a capacitor, so that D will be decreased and C becomes increased. And it is also used to accumulate more charge on the capacitor, so that capacitance of a capacitor is also increased. This is the importance of dielectrics. Dielectric and atomic view. An atom consists of nucleus, that is, nucleus consists of positively charged particles and neutrons. These positively charged particles are supposed to be known as center of positive charge, and electrons which are revolved around the nucleus are considered as a center of negative charge. Both are, this is considered to be a center of positive charge, and this is considered to be a center of gravity of negative charge. Now, when these the center of positive and center of negative coincide, then that molecule is known as non-polar molecules, which have the symmetrical structure and zero dipole moment. Examples are H2, N2, O2 and carbon dioxide, etc. When two center of gravities, that is center of positive and center of negative, do not coincide, and that is they are separated by a distance, then they have the permanent dipole moments. That molecule are said to be polar molecules. Example H2O, HCl, carbon monoxide, N2O, etc. It is dipole. What is meant by dipole? A dipole is an entity which has the equal positive and negative charges are separated by a small distance. That is, positive charge and negative charge separated by a small distance is nothing but the dipole. Positive charge and negative charge separated by a distance is nothing but the dipole. What is meant by dipole moment? Dipole moment is the product of magnitude of either of the two charges and separation between the two charges, that is Q into, then that is dipole moment mu is equal to any charge either positive or negative into separation between the two charges, that is x. This is known as dipole moment. What are the units of dipole moment? Coulomb meter. All dielectrics are electrically insulators, and they are mainly used to store electrical energy. Next, what is meant by dipole? If center of atoms contains the center of positive and center of negative, the center of positive and center of negative are coincide, then it is a non-polar molecule, isn't it? If it is this dielectric material is placed in an electric field, then center of positive and center of negative separates like this, and the center of negative attracted towards the positive plate and center of positive attracted towards the negative place. In this way, there is a separation between the positive charge and negative charge. This is known as polarization. This phenomena is known as polarization. The process of producing electric dipoles by an electric field is called polarization in dielectrics. డైఎలక్ట్రిక్స్లో సెంటర్ ఆఫ్ పాజిటివ్ సెంటర్ ఆఫ్ నెగిటివ్ కోయిన్సైడ్ అయినప్పుడు దాని మీద ఎలక్ట్రిక్ ఫీల్డ్ అప్లై చేయడం వల్ల సెంటర్ ఆఫ్ నెగిటివ్ సెంటర్ ఆఫ్ పాజిటివ్ సపరేట్ అవుతాయి. ఈ సపరేట్ అయ్యే ప్రాసెస్ని ఏమంటారంటే ఎలక్ట్రిక్ పోలరైజేషన్ అంటారు. నెక్స్ట్ polarizability. Polarizability is the induced dipole moment per unit electric field is called polarizability. Polarizability, ability to polarize, is nothing but polarizability. When polarization increases, then electric field is more electric field is applied, more dipoles are separated, more charges are separated. So dipole moment increases with increase in the electric field. Why? Dipole moment is equal to some charge into distance between the two charges. If electric field increases, distance between separation is increases, automatically dipole moment also increases. So mu is directly proportional to E. Mu is equal to alpha into E. Here alpha is known as polarizability constant. Next, what is meant by polarization in terms of surface charge density? Suppose take the dielectric slab. This is a dielectric material. It is having the cross sectional area A, and this is placed in a electric field. It is placed in a electric field, that is this one. We are applying the electric field to this. Here center of positive and center of negative coincide in case of dielectrics. By applying the electric field, center of negative is separated like this, minus q prime. Suppose like a minus q prime. This is plus q, this is minus q. Here inside the material minus q prime, here plus q prime. So positive is attracted towards the negative plate and center of negative is attracted towards the positive place. The separation between them is L, suppose. Then what is dipole moment? Dipole moment is equal to separation between the two, the magnitude of the two charges, that is q prime, here prime, minus q prime plus q prime. So dipole moment is mu is equal to q prime into L. This is dipole moment mu. So polarization is nothing but dipole moment per unit volume. So dipole moment is q prime into L by unit volume. This is area and this is length. Multiply both of these to get the volume. So dipole moment per unit volume is nothing but polarization. Cancel these two, then we get the dielectric polarization P is equal to q prime by A. This is nothing but induced surface charge density. This is nothing but induced surface charge density. This is nothing but induced surface charge density. So dielectric polarization is also known as induced charge density. Remember it? P is equal to q prime by A, not q by A. It is a q prime by A. Q prime is the charge, magnitude of the charge which is separated in dielectrics. Next, dielectric constant. Dielectric constant is the ratio of permittivity of the medium to the permittivity of free space. That is epsilon r is equal to epsilon by epsilon naught. This is also known as K, dielectric constant. It is also represented by K also. K is equal to epsilon by epsilon naught. It is the characteristics of the dielectric material. It has no units. It is also represented, dielectric constant is also represented in terms of capacitance, voltage, potential, force and electric field, like this. C by C naught, V by V naught, C by C naught, V naught by V, F naught by F, E naught by E, like this. Electric susceptibility. when dielectric is placed in electric field, it is polarized. The polarization vector P is proportional to the electric field E. Hence, P is directly proportional to E. P is equal to xi E. Electric susceptibility. When a dielectric is placed in electric field లో dielectric పెట్టడం వల్ల ఏమవుతుంది, polarization జరుగుతుంది. So polarization vector P and it is proportional to electric field. More the electric field, more the polarization takes place. So P is directly proportional to E. So P is equal to some constant xi into E. This xi is known as electric susceptibility. Next, three vectors and the relation we have to study now. So what is meant by electric field intensity? Electric field intensity is the force per unit charge. Force per unit charge. Electric displacement D. This is the surface integral over the any charge surface is equal to the free charges only. Integral E bar dot ds bar is equal to Q, that is D is equal to Q by A. It is only connected to the free charges only. Dielectric polarization. This is already you know that dielectric polarization P is equal to surface charge density. So P is equal to Q prime by A. It is defined as dipole moment per unit volume. So here clearly observe that this is the displacement vector, this is polarization vector, this is electric field vector. These is connected to free charges only, that is positive charge and negative charge which are in electric field. Here P connected to induced charges only, and within the dielectric material, and electric field is connected to both free charges and induced charges, both free charges and induced charges. According to Gauss law, to determine the relation between DEP, first we consider the Gauss law. For that, take the two plates of area of cross section A having the charge Q on positive plate and minus Q on negative plate. These are separated by a small distance. Then what is the, according to Gauss law, electric field in between these two plates? For that we construct a Gaussian surface. Take the small surface area, surface ds, and its direction, draw the normal, then it is a ds bar. Electric field is always directed from positive to negative, so electric field direction is also like this. These two are parallel, so ds bar and E bar are parallel, so angle between them is 0. So E ds cos theta is 0. So E naught into integral ds. So integral is area of the plate is A. So Gaussian surface having the area is also A. So integral ds becomes A. So E naught into A is equal to Q by epsilon naught. E naught is equal to Q by epsilon naught A. This is the electric field without dielectric placed in between the plates, without dielectric. After that, when dielectric is placed in between the condenser, what happened? If the dielectric is placed between the plates, due to the electric field, the center of negative is separated towards the positive charge and center of positive is moved towards the negative charge. Having the charge surface, induced charges are minus Q prime and plus Q prime. Here in case of plate, plus Q and minus Q. We have to determine the electric field in between the plates. For that, construct again Gaussian surface. Take the small area in between the plates. Here also electric field direction is like this and surface direction is like this. The angle between these two is again 0. So E into integral ds is equal to Q minus Q prime by epsilon naught. What is according to Gauss law? Integral over a closed surface E bar dot ds is 1 by epsilon naught times the total charge enclosed within the surface. Our Gaussian surface having the charge q minus q prime. So our Gaussian surface contains the charge q minus q prime, so we write it here as q minus q prime by epsilon naught. So integral ds becomes a. This is the area of the plates. From that E is equal to q minus q naught by epsilon naught a. So we already know that k is equal to E naught by E. K is equal to E naught by E. Dielectric constant K is equal to E naught by E. So E is equal to E naught by K. So already you know that E is equal to Q by epsilon naught A. So substitute here Q by K epsilon naught A. Substitute this in this equation, then we get equation like this. By using the equation, we can determine the relation between these two vectors. So take this equation plus minus q prime by epsilon naught a here, then we get q prime by epsilon naught a is equal to q by k epsilon naught a plus q prime by epsilon naught a. Epsilon naught, multiply both sides with epsilon naught, then we get q by a is equal to epsilon naught into q by k epsilon naught a. Here epsilon naught can get cancelled and it becomes q prime by a. So d, q by a means d is equal to epsilon naught into E plus q prime by a means induced surface density. This is polarization. So d is equal to epsilon naught E plus p. This is the relation between DEP. Next, what is D and P in terms of E? For that, take the value of E as q by k epsilon naught a from this equation. Q by k epsilon naught a. So E is equal to q by k epsilon naught a. Then q by a becomes k into epsilon naught e. We already know that q by a is equal to d. From the definition, integral d bar dot ds bar is equal to q. So d is equal to q by a. This is the relation between d and e. It is also written as d is equal to epsilon e. Next, by using the equation d is equal to epsilon naught e plus p, substitute d is equal to k epsilon naught e in this equation, then we get this equation. From that p is equal to k epsilon naught e minus epsilon naught e is common epsilon naught e, then we get the equation. We already know that the susceptibility means polarization is directly proportional to E. P is equal to xi e. Compare these two equations, then we get xi is equal to k minus 1 into epsilon naught. From that we can get the value of k. This is the it is the relation between the dielectric constant and susceptibility, that is k is equal to 1 plus xi by epsilon naught. Next, what are the boundary conditions